So we're going on to group 14 metals. 10 is in this group. It's used to coat metals that prevent corrosion. So 10 is not very reactive. And so it's used to coat metals that are more reactive. You can use 10 to produce bronze. When you put 10 with copper, you get pewter, which is the bottom one right here. Sorry, if you put 10 with silver, you get pewter. If you put 10 with copper, you get bronze. Yes.
Is silverware, like most modern silverware, 10 with copper?
It just depends on the kind you get. I mean, you can get stainless steel. I mean, really, the majority of what you're going to see is stainless steel because it's a lot cheaper than silver. So silver is pretty expensive. So most of the time, it's going to be steel and not silver. But definitely good silverware, which is expensive, would be mostly pewter. It's going to stay for longer because silver will tarnish somewhat. Lead is a metal. It used to be used in paint and put in gasoline, but it's been since stopped because they realized that it was poisonous. But lead gives paint a yellow color, and so it was used at one time to do that. A lot of metals add colors, and so paints, jewelry have colors because of the metals that you're added to the paint or the jewelry. Yeah.
Do we use lead anymore in anything?
Pretty much nothing. I mean, it's just too dangerous to really be used.
Wait, isn't
So-
it metal?
No, we call it lead, but it's not real lead. It's actually just carbon with some clay. So I don't know why they call it lead because it never was lead to begin with in it.
Oh, I thought it used to be lead. at one point.
Yeah, I don't know how that,
Was it ever mistaken for lead?
maybe. I don't, that's a subject because I really don't know why it was called lead ever. But yeah, if you get pencil on your skin, you have to really worry about it because it's not poisonous to you. It's like a splinter, like any other splinter. You want to get it out if you can, but it's not going to poison you if it stays in your skin.
Wait, lead was in gasoline?
It was, yeah, and that's why you see at gas stations unleaded gasoline because at one time they put lead in gasoline. It was very dangerous to people. A lot of people got sick and died from it.
So what is it in leaded now?
I don't know of anything that lead's in.
Because you can still get like unleaded and
You can't get leaded gas. It's just only unleaded. Yeah, and they just tell you to make sure you know there's no lead in the gasoline. We've been adding lead in the gasoline for a very long time now. Yeah, it just says that people thought that there was lead, and that's why it was called lead. But they just mistook it for lead. But there's never been lead in the pencils. Well, actually, you know what? You can use lead to shield radioactive material. So you could put it, if X-ray machines, for example, if you have those really weighted down blankets they put on
I
you,
was gonna say, I thought those were
There.
lead.
yeah, in that case, it'd be safe because you're not going to be exposed to the actual lead
Isn't it coated in
because
lead?
it's coated in plastic. So yeah, I mean, you can use lead to shield radiation, and so it could be used in the radiation blankets you have on for X-rays. Or if you work at a nuclear facility, the walls would probably be coated in lead because it helps block out radiation as well. So, and those things would be safe because you're not touching it. You're not exposed to it.
How thick does the lead have to be if a nuclear facility were to explode or something?
That would be pretty hard to have happen.
Or the
There are
lead
so
just
many
not move?
fail safes with nuclear power plants that it's almost impossible for that to happen, for it to explode. Unless somebody purposely did it,
Or like
which,
somebody just shot a bomb?
yeah, well, that could happen. That'd be really disastrous. That's never happened before.
Isn't there one in Dallas?
A nuclear power plant? I'm not sure. I mean, there's all over the country. So I wouldn't be surprised if there was some here.
I think there's
Why would
like a
they have them
lake
by
that's
the big city?
banned
Do what?
because of it.
Huh?
I think there's a lake that, like, they advise you not to get in. It might
Oh.
be just an electrical plant,
Mm,
but.
I feel like they wouldn't have them here, like major city.
that wouldn't be smart, that's for sure. Yeah. I don't know. I mean, not like, it could power Dallas, but probably shouldn't be inside the city of Dallas. Group 15, nitrogen, Ryan? Nitrogen group, every breath you take is 78% nitrogen. So by far the majority of air that you breathe in is nitrogen, which is surprising to people when they hear that because we don't use nitrogen in our body, we use oxygen. But even though we use oxygen, it's only about 20% of the air is oxygen. Most of it by far is nitrogen. We just don't use it. We breathe it in, breathe it back out. So the vast majority of air we breathe in and breathe out is nitrogen gas. We don't do anything with it. We take in oxygen, we breathe out carbon dioxide, but the most of the air we breathe out is the atmosphere, which is nitrogen gas, which is just not reactive with our bodies.
Could there become a point where you could purify oxygen to the point where it becomes more healthy for you, but not to the point of unhealthiness?
What do you mean?
Like, could you take out nitrogen from the air?
I just make it more oxygen rich.
Yes.
Yeah, I mean, they do that in hospitals, or like the oxygen tanks would do that. So there's certain rooms in hospitals that have more oxygen than normal, where you can oxygen tank. The problem with that though is that if you were to make the environment full of oxygen, it'd be very flammable. You have a lot more fires. Even adding just a few percentages more of oxygen into the atmosphere would cause a lot more fires every year. So it's actually really good that we don't have more oxygen in the atmosphere, because we can still breathe comfortably, but we don't have as many fires because of that.
Also, don't actually remember. Oh yeah, could you hold your breath for longer if there was lots more oxygen in the environment?
Well, you'd have to have, it wouldn't just be the oxygen in the atmosphere, you'd have to have more red blood cells. So that's really what you'd have to do. And if you have more oxygen in the atmosphere, you probably would have less red blood cells and not more. Like if you live in a mountaintop, you're gonna get more red blood cells. Your body will make more red blood cells. And if you were to then go, wearing
No,
masks too.
Oxygen man.
And if you were then go down to sea level, you would have more endurance than somebody who lived at sea level, because you've had more red blood cells in your body. So actually being in an environment with thinner air would cause more red blood cells, which have more endurance.
Do you know how high above sea level we are?
500 feet, which is
Okay.
really nothing.
Yeah, it's nothing.
It's pretty much right at sea level. So yeah, we're pretty much right at sea level. So we don't, but if you were to train in a mountain and come back down here, then you have more endurance because you would have built more red blood cells. Nitrogen is combined with other elements like oxygen to make nitrates. Nitrate is NO3, -1. Nitrates are found in fertilizer. They're found in medicines. Nitrates and ammonia are both used for fertilizer. Ammonia, NH3, is also used in Windex. So the smell of Windex is ammonia.
It smells so good.
I love
Does it? Wow. Ammonia naturally is a byproduct of your body. It's a poison in your body, but your body naturally makes it. So you can find ammonia in your sweat, in urine. You can see it when blood breaks down, the yellow from the blood.
That's disgusting.
So
Ammonia?
Is that
a
So
little
you
bit.
could use that as fertilizer?
Well, yeah, but you don't have a lot of it. I mean, you have a little bit in your body, but not
Could you
much.
use it in your Windex?
I mean, the amount you have in your body is not gonna be enough to really do anything. You know, it's not gonna really be useful to you. It's the amount so small, it's not gonna really help you.
What was it that it was in and then everyone was freaking out about? Like,
What, ammonia?
yeah, like,
I don't remember.
Oh,
Was it,
like the, was
it's
that
like
the
people,
reason
not like
Blue Bell
freaking
ice
out, but like,
were they
No.
saying it was in chicken?
What was the Blue Bell thing for?
It's
they
'cause,
were just saying it was
they were
like dangerous
producing
and unhealthy
there was
for,
this
it was in
big
some
thing
sort
where they
of
were
product, we don't
producing
know.
But it
what
wasn't
that
chicken?
had, it might be that.
I don't know then.
Was it the bluebell?
Yeah, wasn't it the
Shut
bluebell?
down?
Bluebell? No, that was listeria. They had a
That- it was
bacterial,
that.
they had a bacterial infection.
And then it
But
got
ammonia, I don't know where
and
you would
like
have
three
that in
people
a
died.
product that people were,
They,
I'm not
like,
sure.
Discontinued it for a year. It was horrible.
Group 15, phosphorus, also used in fertilizers along with nitrogen. It's used in match heads. So match heads have red phosphorus, which when you light it converts into white phosphorus, which is very unstable, and that's what you get as the flame, the explosion in the match head.
Is this 15?
This is group 15.
So it's still with the other ones, like the nitrogen group?
So yes, we're still on the nitrogen group. We're just going down the column. So you have nitrogen and then phosphorus. Yeah. Antimony, which is right below the match, is a silver right here. It's a metalloid. Bismuth, which makes really cool crystals, is used in sprinkler heads. So the old school sprinkler heads, the smoke would melt the bismuth and it would cause it to then go off. And you have a sprinkler would open up to douse the fire.
Oh, the smoke.
Yeah, not those kind.
I thought
yeah.
you meant the ground sprinkler.
Oh, yeah, no, yeah, smoke, yeah, it's tech smoke. So we don't have them in this building, but some buildings have sprinklers that will go off when there's fire.
So the smoke would melt the bismuth?
Yeah,
Would
that-
let the water come out?
That's right.
Wait, you don't have
So it's-
sprinklers
We don't, in any room.
here?
We don't, no, you don't have sprinklers in any room over here.
So she's saying the roof sprinklers in old hotels, you know, those things that
Like-
you don't hang your hangers on these? They're all
What?
over the
Like,
roof.
have you seen these before? Like, this is what they look
Okay,
like.
maybe I'm just so tall I start reading things on this thing. Emma,
Usually find them
they're
in
the
like big
things-
gyms.
so
Yeah,
imagine that.
well, yeah, any big building really.
On the ceiling,
Yeah,
Okay?
but not here at the
They're not
school.
ground things.
Yeah, there's none.
We don't have them here at the school.
I've seen them before, but no one probably did not.
Yes.
hang them.
So one time at my cousin's school in Ohio, they did a science experiment and then they like caught the ceiling on fire.
Oh, no.
And then it like melted the pipes.
Oh, no.
And so the like ceiling caved in and then the pipe bursted.
My
So
goodness.
like there was water flooding in the room.
That is
And
terrible.
then she sent me a video and it was like really cool.
Wow. That sounds awful.
So how is that strong enough to hold water? I'm assuming
Oh, it doesn't
it's-
hold water. It's just that when it releases, it just opens up a valve that makes it, so when it melts, it opens up a valve that makes it come out. It doesn't hold the water though, I don't believe.
But wouldn't the valve, like, wouldn't it be clogging the valve where the water comes through?
It might, I don't know exactly the mechanics of it, if it clogs it, or if it just makes the valve open. I'm not for sure. No, it wouldn't build up.
That's what I was thinking. What?
No, the
what
pressure
would be
wouldn't build
so much
up.
Water pressure and just force it out.
No, pressure doesn't build up in a hose or no, it just stays the same pressure.
But can't it be pushed through with more force?
Yeah, but there wouldn't be any more force added to it though. Like in a pipe, you don't have more pressure unless you have air bubbles in it or something. The pressure just stays constant in the pipe.
So it's not constantly on. It turns on.
Well, no, it's just like any faucet. I mean, it's like any faucet where you have you handle which turns it on, turns it off, right?
Oh, okay.
It's
So
just
the
like
water
that.
isn't, like constantly sitting in there.
Well, it is. It's just like any other faucet you have. Where when you turn a handle, it comes on.
Oh,
You open up a valve, water comes through.
okay.
Same thing with these two. Oxygen group. So I mentioned this, 20% of the air you breathe in is oxygen, O2. O2 is what you breathe in as oxygen, but O3, ozone, we talked about this before, lightning will change that to O3. So when lightning or electricity hits oxygen, then you get O3.
Is this group 16 now?
Yes, we're in a group 16, yes. So nearly every living thing, whether it's bacteria, plants, animals, humans, they all need oxygen to survive. They need it for respiration. Respiration is basically burning sugar. That's the only reason why you breathe at all, is to burn sugar. And when you burn sugar, you breathe out carbon dioxide.
Wait, is O3 ozone?
Yes.
Okay.
As we mentioned this before, ozone protects you from UV rays. And so without ozone, you really couldn't have life. Everything would just be burned from the sun.
So we get ozone from lightning?
So some ozone we get from lightning, yes. Yes.
I forget which planet it's on, but doesn't one planet have a bunch of lightning like constantly?
A lot of planets do. A
So
lot
why
of
don't
planets
they
have,
an ozone layer?
because they don't have oxygen.
Oh,
They have other gases besides oxygen. We don't know of a planet that has oxygen on it. They have things like methane and nitrogen and things like that.
could there be a way to transfer that methane and nitrogen into O3?
Well, neither of those have oxygen within it at all. Not get carbon dioxide, then that'd be possible to convert carbon dioxide into oxygen, because that contains oxygen. But other elements don't have the oxygen at all, and then you can't do anything with them. Sulfur is yellow. This bond picture show you sulfur, and it can be a yellow powder, looks like cake, or it can look like crystals like these right here. Yes,
So going back to what Noah said really quickly, could there have been oxygen on Mars?
it's possible. I mean, some people, I mean, they found traces of water and carbon dioxide on Mars, which means that you could have had oxygen at one time.
And also because isn't like the surface rusted?
Yeah,
Or-
they're not sure about that. I mean, they definitely see it's red. And some people say, well, red would mean you have iron with oxygen.
Yeah. with
But
the
others are
oxygen.
saying, no, there's a different reason why it's red. And I forget what other reason there would be. Other chemicals, I suppose, could cause it to be red besides that. But I remember hearing that they said it's not because of oxygen, but I could be wrong about that.
Okay.
Yes.
Why don't they just go travel to Mars and test it? Is it too
Well,
expensive?
humans can't go there, but they do have machines. They have robots that are on the surface that
Why can't humans go to Mars?
it's too far. They don't want to spend the money. It's a lot of money, and it's about a 3-year journey back and forth.
Elon Musk
Well,
is
aren't
trying to
they
make it
trying
possible.
to do it? Didn't they say it'll probably be done by like 2035?
Yeah, 2035.
I mean, yeah, I mean, the private companies might be, now, back when George Bush was president, he did have a goal to go to the moon in 2012 and then Mars in 2020. But then Obama came into office and he just got rid of NASA and got rid of those programs. So we did have a plan at one time to go to Mars through NASA in 2020, but that's since been gone. So now we have private companies like Tesla that might be going to Mars.
Yeah, like
And
it's right now it's Boeing, Blue Origin, and SpaceX, and then they're all SpaceX is partnered with NASA
okay,
to make it like happen, I guess.
so we'll see what happens with that. So sulfur is a nonmetal, and there's different allotropes that can have different crystals. So you can have needle-like crystals in sulfur, or you can have more cube-like crystals. Sulfur is used in paints to make different pigments, along with metals. Sulfur is common in many food products that you eat. We made sulfur before in class. Remember, it was with the fool's gold, and you put it outside with the acid. It's like rotten eggs.
Oh,
So eggs contain sulfur, which you smell. Other food does contain sulfur too, but sulfur can be really smelly when combined with certain gases.
Why does it say nearly all living things? Like, why?
Yeah, there are some bacteria that don't rely on oxygen. Not many, but there are some that live in swamps and below ground that don't need oxygen to survive.
So bacteria are considered living things?
Yes, and so most bacteria do need oxygen, but there are some bacteria that do not need oxygen.
So if we had a machine hooked up to us that would burn the sugar for us, we wouldn't need to breathe.
That's right. Yeah, you breathe only to burn sugar. That's the only reason why you breathe.
So why hasn't anyone come up with something like that for space travel?
The body is so efficient, we cannot match the body's efficiency. We have no machine that's even close to doing what the body can do.
Could you imagine really quick?
We're not anywhere near what the body can do as far as burning sugar.
So what makes the body so efficient? Like,
It uses certain chemicals that can burn the sugar very efficiently, and we're not able to use the chemicals that the body uses the same way.
So I was just saying, why is it so complicated? Because we know so much about the body. People
Yeah.
just go in and use those chemicals. make
Yeah,
their
it's
own
not that
machines.
simple. Yes, I mean, we cannot do what the body does very efficiently.
What if you don't eat sugar?
If you don't eat sugar, oh, that's a good question. Your body converts it into sugar. So like if you eat pasta, for example, or bread, that contains a lot of sugar. Potatoes contain a lot of sugar. Even vegetables contain sugar. It's just not pure sugar. So there's starch that can be broken down into sugar. And so a lot of food that you eat is not sugary, it's not sweet, but there is starch that can convert into sugar. If you only eat, say, protein, that's it. If you're just like a meat-only diet, your body can convert protein into sugar. So your body is able to convert between fats and proteins and sugars to get what it needs.
So everything is converted into sugar.
It can be if it needs to be, yes. Selenium is also an oxygen group. We need that in small amounts in our body. And then tellurium and polonium are metalloids.
Not lipstick.
No, that's a little, looks like a missile or a bullet. It's a ring.
It's a ring.
And polonium glows green. So one time they had them as prizes in cereal, where it's radioactive, and so it would glow green.
Is it
And-
like harmful?
Yeah, radioactive material is harmful to you, but at the time they didn't know that, so they gave it to kids in their cereal boxes.
What a great idea.
Yeah.
That'd be pretty
Did you ever-
legendary.
No,
Radioactive.
no, this is back probably in the 50s or even earlier.
Yeah, with
It's a long time ago.
So then would, in return, would the cereal glow?
Would really be green.
Would it glow? If it was there for a very long time, it would, but in the small amount of time it was in the cereal box, no.
So if we found like one today, like a box with.
Maybe, might be glowing, yeah. It could, yeah, the whole box might be glowing. Does everybody have these down? Okay, so that's end of 6.1. Gonna close this up.